Hello students, straight back again. Today we're going to be dealing with section 7.3, names and formulas for ionic compounds. This will be what we learn in this section will carry all the way through chemistry. This area we call nomenclature, dealing with names and formulas. So our objectives are relate a formula unit of an ionic compound to its composition, write formulas for ionic compounds and oxyanions, and apply naming conventions to ionic compounds and oxyanions. Review vocab: a nonmetal element, generally a gas or a dull brittle solid, poor conductor of heat and electricity. New vocab we're going to have formula units, monatomic ions, oxidation numbers, polyatomic ions, and oxyanions. Main idea: written names and formulas for ionic compounds. A cation appears first, followed by the anion. Very, very key concept. And it's always going to be cation, anion. Time to deal with ionic compounds. Writing names and formulas for ionic compounds. A cation appears first, followed by the anion. So in order to deal with chemists from all around the world, we've developed a standardized system of naming compounds. Formula unit: simplest ratio of the ions involved. And we have monatomic ions, one atom ions. So all these things are some of our common monatomic ions. And group 1 plus 1, group 2 plus 2, group 15 is minus 3, group 16 minus 2, group 17 minus 1 are our typical charges. You will need to know the information in this chart. Yeah, as we get into some of the transition metals, they can have multiple charges. Just pulling a couple of them out here. We got cobalt down here. Can be a cobalt with a 2+ charge or a cobalt with a 3+ charge. And there's chromium. Chromium can be a 2+ charge, or chromium can be a 3+ charge. A 2+, 3+, very common in here, but there are some other ones you're going to see also. See some 1+, be a few 4+ in there. And when we talk charge, I also use the term oxidation number, oxidation state, and charge. So when we're dealing with ionic compounds and ions, oxidation number and charge are pretty much interchangeable. So like in the names, a symbol of the cation is always written first, followed by the symbol of the anion. Subscripts represent the number of ions of each element in an ionic compound. Total charge must equal 0 in an ionic compound. This will be a very key thing as we're figuring out what the formulas are. Charge must equal 0. There we have some things we call polyatomic ions made up of more than one atom. Polyatomic ions exist as a unit. We never change the subscripts of the atoms within the ion. If more than one polyatomic ion is needed, we place parentheses around the ion and then use a subscript outside the parentheses. There's a couple common polyatomic ions, the ammonium ion and the phosphate ion. Here's a list of common polyatomic ions. In the class, I'll give you a list of them that you will need to memorize. For many of them, you'll be able to look them up in a chart like this. And then we got oxyanions, a special type of polyatomic ion. It's an element, most of the time non-metal, bonded to one or more oxygen atoms. So things such as nitrate, nitrite, sulfate, and sulfite. Yeah, and the key ideas here, the 8 ion will always have one more oxygen than the 8. 8, one more oxygen than 8. And some of them will also use a prefix, either per or hypo. And these mean one more oxygen or one less oxygen. And here's where we talk about that. So we get the per and 8. And we just get 8 and 8 and then hypoite. Things like the chlorates run through all these, and any of the other halogens will do the same thing. And a few others run through all of them. Some of them only have 2 oxyanions associated with it. Some of them have all 4 of them. So here's where they bring in the term I mentioned earlier, nomenclature, systematic way of naming compounds. Name the cation followed by the anion. Monatomic cations, we use the element name. Monatomic anions, element name and IDE. And distinguishing different oxidation states of the same element, we use parentheses and a Roman numeral. And when the name is compound contains a polyatomic, name the cation followed by the name of the polyatomic ion. Here's a little flow chart that might help you to write out your names, figure the formulas up for ionic compounds. In class, we will go through a lot of examples of how to write formulas for ionic compounds. Subscripts would you likely use for an ionic compound containing an alkali metal and a halogen. Alkali metal, group 1, so it has a 1 plus charge. Halogen, group 17 with a 1 minus charge. Got the same charges, equal and opposite. That means we'll just have a 1 and a 1. Name of the compound, CaOH2, Ca, calcium, OH, hydroxide. So that's all for now. Till next time.